Hey students, this is lesson 6.1. In this lesson, we're going to learn how to classify numbers as natural, whole, integer, rational, and irrational, and put them in order. This first page is just a vocab and a little bit of a review. Go ahead and you can do this on your own. Just pause right now and you can check back for the answers. So go ahead and check your answers here. I'm going to add a few more perfect squares. We're going to use them for a problem later on. So we'll go just a bit further here. You can go ahead and make this chart on your paper. And so here's the numbers, and then the number squared. So we made it. We went up to 12 here. We're going to go 13, 14, 15. 16, 17. 17 squared is 289. 16 squared is 256. 15 squared is 225. 14 squared is 196. And 13 squared is 169. So have that chart handy a little bit. We're going to use that chart. All right. So simplifying square roots, here's how that works. It says, and we're going to use those perfect squares in the table that we just had. It said, what is the simplified form of each expression? So the square root means a number multiplied by itself that equals this base inside there, that 25. So if we go back a page, we're going to look for the number 25 in our number squared chart right here. And we can see that the number is 5. That means 5 times 5 equals 25. And so for this answer, since 5 times 5 is 25, and I'll just write this over here, we know that the square root of 25 equals 5. Okay, now the square root of 4 over 81, we can do that by, just like powers, we can separate the square root into the numerator and denominator like this. And the number multiplied by itself that equals 4 is 2, because 2 times 2 is 4. And the number multiplied by itself that equals 81 is 9, because 9 times 9 is 81. So on this page, when it says got it, I'm going to let you try and do that yourself. And then you can check back with the answer. So you should be pausing your video right now. So now you can check your answers and see if you're right. Okay, the next thing we're going to do is learn how to estimate a square root. It says, what is the approximate side length of a square that has an area of 220 square inches? So the area, that means the space inside here, is 220. And we would get that by multiplying the side times itself. So we're looking for what number times itself is about 220. And if you go back and look at your chart on the first page, you will see that right here, 14 squared is 196 and 15 squared is 225. So keep those in mind. And we are going to, we want to get as close as we can to it. Since 14 squared is 196 and 15 squared is 225, we're going to just to the nearest whole number, we're going to say that x is equal to, or the side length of the square, is equal to 15, since 225 is closest to 220. Okay? We can use a number line to do that also. So again, you can, I guess I'll go through this one to help you think about this. So this says, we want to know what is the value of the square root of 34. It's the nearest integer. Well, we know that 25 is right here, and that's a perfect square of 5s. So that's equal to 5 squared. And we know that 36 is a perfect square, and that number goes here. That's 6 squared. And we're looking for the integer that's closest to 34. So by looking at this, so thinking about this, so the square root of 25 is 5, because 5 squared is 25. The square root of 36 is 6. So the square root of 34 is really close to 36. So since 34 is closer to 6 than to 5, the square root of 34 is closer to 6 than 5. So the value of square root of 34 is nearest integer is 6. I should have said, since 34 is closest to 36 than to 25 there. Sorry about that. All right, let's move on. You can classify whole numbers using sets. A set is a well-defined collection of objects. Each object in a set is called an element of the set. A subset of the set consists of elements from the given set. There's a few subsets of numbers that we're going to have to know. One of them is natural numbers, and natural numbers are just like counting numbers, 1, 2, 3, 4, 5. This means we're going to continue in that pattern. Whole numbers are counting numbers plus the number 0, so it's just counting numbers starting at 0. Integers are positive and negative whole numbers, so we're going to include these negative numbers all the way to negative infinity and up. And a rational number is any number that can be written of the form a divided by b, where a and b are integers. So basically, a rational number includes fractions and decimals, because all decimals that are either repeating or terminating, you can write like that, and we'll show that in a little bit. So let's just look at this set of numbers here. Numbers that are not rational numbers. So rational numbers are fractions, basically, and decimals. The numbers that aren't rational numbers are numbers like pi, and that's because the decimal for pi never repeats and never ends. So it can't be written as a fraction using integers. So square root of 5 is also like that. If you put it on your calculator and estimate that, you'll notice that the numbers are like pi. They go on forever and ever and never repeat. But these other numbers, this number here, 0.9 repeating, is actually 9 over 9, which is 1. So that's definitely a rational number because we can write it as a fraction. And 7.35 is the same as 735 hundredths, which is a ratio of 2 integers. So we don't want to cross that one up. So the numbers that are rational numbers are negative 7/4, 0.9 repeating, and 7.35. Okay, so an irrational number cannot be written as the quotient of 2 integers. That's important. So we're going to talk about the subsets. Now 12, if you look at these sets up here, 12 is in this set, this set, this set, and it's also a rational number because we can think of it as a fraction, 12 over 1, so we can write it as the ratio of 2 integers. So we're going to say natural, whole, integers, I'm going to abbreviate it like that, and rational. Okay, this number, since the decimal ends, it's not an integer or a natural or a whole number because it has a decimal. But since the decimal ends, it is a rational number. There is a fractional form that we can write that number in. I'll write it over here. It's negative 501,479 over 10,000. Actually, we need one more zero over 100,000. That's equivalent to that. The square root of 21, if we approximate that on our calculator, I'll do that here. So on the calculator here, we want to do the square root, and you might as well know where that is. You press second and then the x squared button there. And we want 21. I'm going to hit enter. And notice that the number goes all the way to the edge of the screen. And we don't see any pattern, any repeating in there. If that happens when you do a square root, then it's an irrational number. There's no way to write that as a fraction. So this number here is irrational only. And if it's irrational, it's not going to be natural or whole or any of those numbers. All right, so go ahead and try this. Got it here. I'll pause and you can give it your best shot. All right, so check your answers there. The last thing we're going to do here is talk about comparing real numbers. And in this, we're just going to try and figure out which number is greater. And I think we're going to use our calculator to help us do that. So we're going to change them both into decimals. So on my calculator, I want to do the square root of 34 and 5 4/5. The square root of 34 is that number. 5 4/5. I'm going to write it like this. I'm going to do 5 plus, and then I'm going to do the 4 divided by 5 after to get that. So that's 5.8. So since the square root of 34 has a little bit, has some stuff after the 8 there, the square root of 34 is bigger than that. So on here, we are going to say the square root of 34 is greater than 5 4/5. All right, you can go ahead and try this last gotcha here, and then we'll do the rest in class.